In this video, we are going to understand how we can actually model linear programming models in MS Excel solver, in which we can actually solve these problems to optimality. So that's very important because you can model any problem in this world, but if you cannot solve it really, you cannot really use it in practical life. So the first thing to do in spreadsheet modeling or MS Excel solver is to set up the logical format. So you have to transfer, remember we transferred the words into math, and math into linear programming structure, and then we need to actually convert linear program structure into MS Excel format. So everybody has different style. My style might be different than yours, but you have to really set up the logical format in your spreadsheet. You have to define the cells for the decision variables, define separate cells for the objective function and each constraint. And since we deal with linear functions, avoid using these Excel functions because those are non-linear functions, okay? So let's go to Sklenkowski Excel workbook. So in your Excel files, okay, and go to the first model that says Sklenkowski company. Well, what you have here is that the first table is your input table. Basically, you see for the fabrication department and finishing department, Jordan nail products requires, for example, for fabrication 3.5 hours, and cross models requires 4 hours, and for finishing 1 and 1.5. And we do have the daily limits for them already written out for you. As you can see, there are no formulas here. Those are just the values that we got from the case. And for each model of Jordan nail, for each product of Jordan nail is going to help us make $50 profit, and for each deer crest we are going to make a $65 profit. So here is my template. For my model template, what I used is that, so these highlighted cells are going to be used for my decision variables. Basically, this cell represents the number of Jordan nail products here, and then this cell represents the number of deer cross models here. As you can see, those are empty. And these numbers here, right there, it's going to, this cell is going to multiply this decision variable, which is the number of Jordan nail product, by 3.5, which is the amount of hours that Jordan nail product requires in fabrication department. And then this cell is going to give me the total amount of fabrication time the cross model is going to require, okay? And then I will add them up so that I can calculate how much time I will require in fabrication department, okay? So basically this cell, the sum of these two cells are going to be written here, okay? And then finally what I will say is that in the Excel solver, I'm going to show you how this cell must be less than or equal to this cell 84, right? So similarly, for the finishing department, I have to control how much time Jordan nail products are going to require. Well, at this point, I don't know it. At this point, it shows 0 because I don't know how many Jordan nail products or D-class models I'm going to produce at the optimal solution. Well, you can play with it, right? You can make this 2, you can make this 4. As you can see, the numbers are changing right now. This is a feasible solution, right? Because 23 is less than 84, and then 8 is less than 21. We are satisfying all the constraints. Is this the optimal solution? I don't know, right? We have to solve this problem to optimality. It can be an optimal solution because it is feasible. Well, let's make this 10, okay? And then see what's going on. This is still an optimal, well, a feasible solution. Oh, we are not done yet, right? So we have to also take this market mix into account, right? So the market mix says that if you go to the text here, it says the company wants to determine, well, the company anticipates selling at least twice as many deer-class models as Jordan nail models, and we wrote this constraint as deer-class minus to journal greater than or equal to 0. So let's go back, and then the market mix constraint. Sorry, let's make this full screen one more time. So here, C14, which is the deer cross models, right, minus 2 times Jordan should be greater than or equal to 0. Well, right now this is minus 16, so this is not a feasible solution. It already violates this constraint, so that cannot be a feasible solution. Well, let's try to make this, let's say 4, and then let's make this 10. At this point, this is plus, okay, this is a positive value, so it satisfies this constraint. 54 is less than or equal to 84. 19 is less than or equal to 21. This is completely a feasible solution. Again, is this the optimal solution? We don't know, it might be, but Excel Solver hopefully is going to give us that answer. So total profit we can make out of Jordan is $200. Total profit with the solution we can make out of the crash is $650. And then if you sum them up, this is the total profit. So we would like to maximize whatever we have in the cell. So let's go to Excel Solver. So I'm using a Mac, so it should be right here. Okay, let's make this full screen one more time. So in my Excel Solver screen, so I got this set objective. So I will get rid of them so that I can rewrite as I'm teaching. Okay. It says set objective. So my objective is to maximize the total profit cell right here. Okay, I selected my total profit cell, and my objective is to maximize it. Definitely, I don't want to minimize my profit. I would like to maximize it. It says by changing variable cells. So which cells you are going to change so that that helps you maximize it. I will just go ahead and select my decision variable cells right there, and subject to which constraints, right? So I got mainly 3 constraints. The first one